Hello student, here is the question that magnetic field at a center of a current carrying wire as shown in the figure. So you can see here is the wire which you have. So this element of the wire is passing through the point where you have to calculate the magnetic field. So its magnetic field will be 0. So V1 magnetic field will be 0. Now calculate the second element. This is the second element which you have, and this element magnetic field will be equal to. So for an arc, magnetic field is given by the formula mu naught into I upon 4 pi r into theta. Okay, here is r is the radius. So here is I am writing that r, that's radius, and that's theta. So just put the values, this value, that's a mu naught into I, current is I, and 4 pi, the value of r, that's equal to from the center, that's value is equal to 2r. So just put the value 2r, and theta is equal to, that's 60 degree. 60 degree is nothing but just the pi by 3. Okay. So here pi and pi will cancel out, and you will get that's a mu naught into I upon, that's multiply by 12 multiply by 2, that's a 24r. Okay, so direction will be, and this direction will be that's move in the direction of rotate your fingers in the direction of current. You are getting the direction outward. Okay, so here is the it is in outward direction. Now next element is this one, and this element is also passing through the point where you have to calculate the magnetic field. So due to this also magnetic field will be 0, and here is the next element which you have. This element, due to this element, magnetic field will be writing due to this, that's B1, you'd say B2. Mu naught into I is flowing upon 4 pi, the radius of that element is equal to r, and the theta, that's equal to pi by 3. So you will get from there, that's it will be equal to mu naught into I upon 12r. Okay, and the direction will be equal to, so direction, rotate your finger, the direction of current, you are getting the magnetic field inward at that point, so it's inward. Okay, rest of the element which you have, it is passing through that, so it will be equal to 0. Okay, so that element is also passing through that O, so it will be equal to 0. So net magnetic field will be equal to that arc, and due to that arc, and direction you can see, so net magnetic field will be equal to B net, you are writing over there, that's a B net. Net magnetic field will be equal to, that's equal to mu naught into I upon 24r. Okay, and you can see that that value is more as compared to that value, because if you divide that by 2 you will get this one. Okay, so this value is more as compared to this one. Okay, so I can see that's I can reverse this direction, and I can write it as, that's mu naught into I upon 24r. Here is direction is outward. If I am taking the minus sign, so it will become inward. Okay, now add these two values, you will get the minus 24 plus mu naught into I upon 12r. Okay, so net direction will be in. So you just solve it out, you will get the mu naught into I upon 24r positive. Okay, so direction will be inward into the plane. Okay, so here it matches with your answer, mu naught into I upon 12r and into the plane. So here is the into the plane. Option number first is the correct answer of this question. Okay, thank you.